Radius, diameter, chord, all pieces of a circle we are now very, very familiar with. Let me introduce a fourth piece to you. Tangent. Now, we have heard that word before when we talked about SOHCAHTOA, sine, cosine tangent. Totally different. All right, please separate the two. This is a tangent of a circle. And it's pretty easy definition. I need a line. Line. Arrows at the end. Intersects the circle one spot only. It's got to intersect at one and only one spot only. Anything less, anything more is not a tangent. It's got to intersect at one and one spot only. And instead of saying spot, let's have a little self-respect for that spot. That spot where it intersects is called the point of tangency. So B, point F, those are all points of tangency, where your tangent intersects the circle. All right? I'm pretty clever, huh? Those mathematicians, whenever they made that up. Oh, let's just call it the point of tangency. Clever. Look at my diagram to the right of that, though. I want to go through each one of those and describe why they're not tangents. So let's go through the easier ones first. RS. Why is an RS a tangent? It doesn't even intersect. How about PQ? Yeah, twice. We said once and only once. There's no wiggle room there. All right, let's get controversial here. TU. Why is that not a tangent? Okay, it's a radius, but also it's not a line. Hey, woohoo! Hey now. That's why I put it in there. It's got to be a line. And if I made this into a line, it would intersect in how many spots? 2. And then finally, why not WV? It's a ray, and if I made it into a line, again, I hit in 2 spots. So it's got to hit exactly once, and it's got to be a line. Oh, good. All right, let's add to your, I don't know what you want to call it, tool belt of facts here. That involved, a whole bunch of inscribed angle facts. Now let's learn 2 tangent facts before you leave today. To the right of theorem number 1, can you draw just a circle for me? We're going to build theorem number 1 together instead of just reading it out of the box. So somewhere near theorem number 1 there, draw yourself a circle. And then draw yourself a tangent line. I don't care where it is, what angle it forms. Draw yourself a tangent line. Should only intersect at one spot. And label your point of tangency, kids. Go ahead and name that point. All right, everyone's got a tangent line, right? Point of tangency. Looks good, looks good. All right, give me a center of your circle, please. Put a center inside your circle. Put a center in there. And here's the last piece. Draw a radius in your circle, but the radius has to go to the point of tangency. So final step, draw a radius in that goes to the point of tangency. If you have this, if you have a radius drawn to a point of tangency, those two will be perpendicular, forming a, there you go. There's fact number 1. Radius drawn to a point of tangency is perpendicular. All right? We will use that in proofs coming up. But before you guys can get to proofs, how can I use this in just your standard algebra problem? Where can I use this? All right, let's look at number 1. Anything that looks to be tangent or appears to be tangent is. Find angle x. Well, you're not doing anything unless you know this fact we just went over. What can you add to my diagram now? What can you add to this diagram? 28, what can you add to it, Tyler?
Right angle.
Yes, you can, where the radius and tangent meet. I can confidently say that's a right angle. And now this becomes a pretty easy problem, I hope. Let me know how you're going to find x. 4, how can I find x?
90 plus 58 plus x is equal to 90.
There you go. 180 minus that 90 we just wrote in, minus the 58. And what are we looking at here? Just making sure you're paying attention. 10. One job. No excuses. 10. 12.
32.
What do you have? 32. There you go. All right. Because they form right triangles, not only can we do 180 inside, but we can do a little something on the outside with the sides. All right. BA is tangent to circle C. Again, we just look at this. I know it's fresh in our minds, but we can just look at this diagram from now on and throw down a what? 11. What can you add to my diagram?
B is a right angle.
B is a right angle. Yep. So I'm not worried about 180 degrees now, but I can use a little theorem we've been using all year long, dealing exclusively with right triangles and their three sides. And that would be 8. 8. Not here. Okay, thank you. 23. Pythag. Can you identify both legs here for me? What are the two leg lengths in this right triangle? 19. X squared plus 8 squared equals, ooh, can we do the hypotenuse here? How do you write how long the hypotenuse is? It's 27. 2 squared. I need the whole length though. Can't just have 2 squared and x squared. The whole height. CA. How long is CA altogether? What do we have?
2 plus x.
2 plus x. I'm going to reverse it on you and go x plus 2 all squared. Everyone all right on how the hypotenuse x plus 2? All right, how's your algebra? 64. Oh, here we go. Please don't be an embarrassment to either me or your future Algebra 2 teacher who doesn't even know you yet. X plus 2 squared is not x squared plus 4. Come on. How'd you get 64 here? What'd you do? How'd you get 64? 8 times 8, right? A number times itself. Well, same thing here. X plus 2 times x plus 2. Go ahead, double distribute. Oh. We're getting x squared, right? Combine the two like terms in the middle. You should have a 4x. And then do that last distribution and 4. All right, so that's what I should get. Ooh, what's your move now, kids, huh? Ooh, I know we don't, some of us are getting nervous. I see x squared. That usually means factor. I can't do it. All right, but you can't factor unless, we could talk about it, but we're not doing it unless one side. Yeah, when it's equal to 0. All right, let's move over x squared plus 64. What's going to happen when I move the x squared over? See ya! They're gone. So lucky you guys that don't like factoring. You don't have to here because those x squareds will cancel. And I hope you can solve something like that without factoring. We'll see. Yes, the x squareds are gone. $19. Woo. Yes, it does. So we all right if we see this? Yeah, yeah. Okay, look at number 3. I look at number 3. What are you putting on your diagram? 28.
Right angle.
Where?
CBA.
Yep, thank you. Oh, whoa. You're pretty confident one leg length is what? What's the one you're confident in? 25?
10.
Leg. X squared. Oh, look what I'm. Whoa, CB, the other leg, completely blank. but I'm still going to use Pythag, completely blank. Not for long. Everyone see what I labeled 3? Name that. Name that. What is that in the circle that I just labeled a length of 3? 24? Radius. So that means in that circle, you draw me any other radius in, guess how long it is? 3. In a circle, all the radii, plural, radii, everyone hear that? Double I, not radiuses, radii. All the radii are the same length, the same circle. So that's got to be 3 as well. And then how about the hypotenuse length? A little easier than the last one. 10? I'm sick. Suck it up. 20. 10 squared. Yep. There you go. Everyone all right? Why that's 3. In the same circle, all the radii are congruent. X squared plus 9 equals 100. Move the 9 over. It's not 90. I know some of you guys like to do that. New math. 100 minus 9 is all of a sudden 90. Oh, shoot. I'm sorry. 91. And then, yep, you take the square root. And you guys are in what level here? What level? Yeah, honors. Yeah, that's what they tell me. I'm going to save you guys some time. You don't have to go divided by 4, divided by 16, divided by 25. There is no perfect square that goes into 91 evenly. So we're just going to leave it. Square root of 91. How about that? I know some of you guys like to just go at your own pace in the notes instead of staying with me. Hopefully you didn't do that for number 4 because we're going to work smarter, not harder here. Okay, we're going to work smarter, not harder. All right, what are you putting on your diagram first? I look at that diagram in 6. What can I put on it? Yep. So a little Pythag action, even though one of the legs is missing. All right, give me the lengths of both legs. Don't do the hypotenuse yet. I'm telling you, we're going to work smarter, not harder. 12, both leg lengths. 12 squared. And then we also had a 9 come in there, right? Because at CB is a radius. Any other radius, I know, is also 9. Now, instead of putting x plus 9 here, double distributing, I am going to have to factor because it won't cancel out this time. How about we do this? Let's just solve for the hypotenuse. And then how can I find x at the end? If I know the hypotenuse length, how can I find x? Subtract it from 9, or subtract 9 from it. All right, now look, could I do x plus 9 squared, do my double distribute, move everything over, factor? Yeah, it's still going to work. It's still going to work. It's just more efficient, I think, doing it this way. So we'll let you guys crunch the numbers so I can find the value of C. I don't want to know x. I want to know the length of the hypotenuse, please, by doing Pythagorean theorem here. 18? 15. Good. So the length is 15. Makes the problem a little easier now. X is 15 minus 9. Length is 6. Uh-oh. Uh-oh. I'll just let you soak that in for a second. Oh boy. Oh boy. Oh boy. Okay, so here's where we are. You know one fact about a tangent. Radius drawn to a point at tangency is perpendicular, forms a right angle. There's one more fact I need you to get. And instead of just giving it to you and say writing it down, I want to show why it's true by doing. Usually I'd be hearing some applause here. This is only a one-time deal right here. One-time deal. You're not going to see any more of these. We're back. We are back, aren't we? We haven't seen this since midterms. Midterms. Here we go. Yes. Let's do it. Get me BA congruent to BC. Anything's in play, by the way. Circle facts. Heck, I could go back to Unit 2. Anything is fair game here. Need to get BA congruent to BC. So let's go back to when we used to do this. BA congruent to BC will not be true unless. What's true first? Thank you, Kyle.
Triangle.
The triangles are congruent. Remember the old CPCTC days? That's what this proof's going to be at the end. So here you go, kids. Get me those two triangles congruent. 5 methods. Anybody? I don't want to write them down. 5 methods. What do you got?
Angle.
Side, side, side. HL, the forgotten one. Angle, side, angle. Side, angle, side. Angle, angle. Side. Thank you. Angle, angle, side. No side, side, angle still, even in April. All right, get me some sides or angles here, kids. Come on. You can use anything you want. Give me some sides or angles here. Woo! 25.
BO.
Yeah, we had to do it, right? There had to be that guy. Yep, here we go. BO congruent to itself. Told you we'd go back to unit 2. All right, the easy one's out. Now you got to have some circle facts here for me, unfortunately. Nothing else. You can use nothing else from this year except circle facts now. So anything we've talked about today in particular, anything we've talked about today in particular that you know is true right now. 22, anything?
OA is congruent to OC.
Don't say a word. Look at you. OA is congruent to OC. Yeah. Okay, so what are they? And if they're all in the same radii, and if they're all in the same circle, they're all congruent. Here's the reason, because we haven't written down a formal reason yet. In a circle, and I will tell you guys at the end why that is non-negotiable. That has to be in this reason. In a circle, all radii, double I, are congruent. So why do I need this little statement in a circle? Take it out. What's it read? All radii are congruent. So every single radii that exists, they're all the same length. I don't think so. So now you understand why you need in a circle. All right? In the same circle, yes. All right, wow, look at you guys. I got 2 pairs of sides, and I know it's not going to be the 3rd pair of sides because I'm trying to prove that. So get off AB congruent to BC. That's not happening because that's what I'm proving. So it's got to be an angle somewhere. There's got to be an angle that exists somewhere that's congruent. Where is it? We just have done all this work today. 20. Bridger?
Is angle A congruent to angle C?
Not yet, but it will be.
Because they're both right angles.
Radius drawn to point of tangency. Yes, that's today's fact. First one today. Didn't we already? Boom, boom, right? That's what we would put on our algebra examples. But here's the thing, though, and I'm glad we're going over this now instead of in 2 days when we start actual proofs. You cannot say in step 4 that angle A and angle C are right angles. The theorem doesn't say they form right angles. The theorem says radius OA drawn to the point of tangency, which is on AB, are what? Nowhere in that theorem can you see the word right angle. It says these two are what? Okay, so you have to tell me they're perpendicular using that theorem. What makes them right angles? You know that already, and we'll talk about that in step 5. And then the same thing for OC and CB. All right, this is our first time officially writing this out. Radius drawn to, I'll spot you that. Radius drawn to, where's it got to be drawn to? 16? Well, not anywhere on the tangent. right? Because I can't draw it here or here. It's got to be radius drawn to point of tangency. Oh, that's a good spelling word. Is perpendicular. So again, this theorem only allows you to say those two are perpendicular to each other. No right angles are formed yet. All right, so now angle A and angle C are right angles now. Dig deep. Why? Get back. Hey, just get back on the bike and start riding again. That's all this is. Get back on your proof bike and start riding again. Why are those now right angles? 9. There we go. Look at my diagram. You're going to have side angle side there? Side angle side? Is that side angle side? No, those right angles aren't in between. What method? Anybody see the method? Not side angle side. Angles, right angles not in between. Instead, it's HL. Yeah. Hypotenuse OB, leg OA and OC. Good thing. Oh, HL. How about that, huh? We're just jumping back in the proofs for the first time in like 3 months, and the guy just slaps you with an HL proof. Welcome to honors. Before I write their congruent by HL, anybody remember the in-between step? Got to say, Emma? Got to say they're right triangles. Triangle ABO and triangle CBO are right triangles. And I know some of you may think you're about to challenge me and brave enough to challenge me and say, why don't I need the right angles congruent? You could, you don't need it because it's an HL proof. Okay, HL proofs, I don't need the right angles congruent. Why are they right triangles? Right triangles have right angles. All right, go ahead. This is 8-step proof. Now you finish it. Tell me the triangles are congruent, followed by CPCTC. And then we'll talk about the theorem we just proved. All right, so here's your second. So you have radius drawn to a point of tangency, forms that right angle. They're perpendicular. And here's your second one of today and the last one for tangents. From now on, we can just say, oh, BA and BC are the same lengths. Here's why. Here's the theorem that says it. Anybody, what can we call BA and BC? What are those? Tangents, but aren't tangents lines, right? So instead, let's just narrow that definition down a little bit. Let's write tangent segments. All right, so if you have 2 tangent segments drawn to, look at your diagram. Where are those 2 tangent segments drawn to? Best description where they're drawn to. Thank you. The same point, right? They're both drawn to point B. So if you have tangent segments drawn to the same point, what'd you prove by CPCTC about them? They're congruent. There you go, kids. If you'd like a little device to remember this theorem by, the crazy kids in the past, honors kids, used to call this the party hat theorem. Okay, sure. What do I got to put one of those bad boys around, fit it around the chin? All right, party hat theorem. If you ever write party hat theorem in the reasons column, you will be shamed. I'm marked off for it. All right, that's a no-go for me in the reasons column, party hat theorem. Questions about the tangent segments? All right, yes, I can use it in a proof, but how do I use it in some algebra questions? Here you go. Take a look at number 1. Here's where I can use this theorem. What is the perimeter of this triangle? Well, I know perimeter from my elementary school days is all sides added up. We know one side's 7 already. But what about the other 2 sides? Here's where I use this tangent segment theorem. Everyone see where it says 4 up here? And everyone see another tangent segment drawn to the same point? Right here. That's got to be 4 based on the theorem you guys just proved. They're both drawn to the same point. Same thing down here. If this is 5, this tangent segment is also 5 centimeters. It's drawn to the same point for a total distance of 9. And then finally, you got 3 centimeters. Yeah, that other tangent segment, 3 centimeters. So that third side was 8. And what are we looking at here? Perimeter of 24 centimeters. So everyone see where we're using that theorem now. And then 2. Ooh, I already know 2 out of the 3 sides. How about that third side? Is this missing tangent segment 6? No, you're not picking up the theorem then. They're not drawn to the same point. This one's drawn to here, and the original 6 inches is drawn to here. They are not both 6 because they're not drawn to the same point. Can I get there though? All right, 6, and this has got to be 6. Making, what about this piece? Work around here for me. 3, right? 5, and then the missing one. There you go. Now we're picking it up. So we're looking at what here? 17 and 11, 28 inches. And I am going totally hands-off with the next 2. Use any of the circle facts we've talked about, please, to see if you can figure this out. I will give you a hint with number 3. How many degrees in every quadrilateral? How many degrees in every quadrilateral? Okay, 360 in every quadrilateral. Go ahead, talk it through with your crew, by yourself. We'll regroup here in about 2 to 3 minutes. On number 3, what can you automatically add to the diagram? Talked about it today. Talked about this fact today. What can you automatically add to your diagram here? 26? 2, not just 1. We can fill one in here and here. And now you know 3 out of 4 angles in that quadrilateral, huh? 360 minus a $130 minus the 290s. Woo, 50. No tangent lines in number 4, but I do have 2 what drawn in? 2 sides of those triangles are what in the circle? 17, these 2 are? Yep, they're both radii. Yep, you're good. Makes them congruent. Now I get away from circles and go back to triangles. What type of triangle am I working with here? 7? 7? Isosceles, what's across from the congruent sides? So if that's 50, other base angle was 50. Yep. 180 minus those 2 50s. Angle X. Don't know what I'm writing. 80 degrees. All right. We only got a couple minutes left, so I don't want to expect you to get your textbooks. Got to dig deep with the assignment. Woo. That's a lot of facts right there. More to come tomorrow. Yep.
Take a test today after school.
Not today. Nope. Tomorrow's fine with me.
All right, thanks.